Hi, I'm Robert Lyons, and this is my video submission for CS4096 AI for Games. In this video demonstration, I will run through and demonstrate various game AI techniques that we implemented, as well as briefly explain how we implemented these systems. Here I have the game up and running from the main menu, and in this horror-inspired game, there are 3 different AI agents. Each demonstrate pathfinding and perception, implemented via state machines. The AI agent that I primarily worked on would be the one who is blind, and thus he perceives based on sound created. He is in this room here, and when the door is originally opened, he will come over, and provided you don't get too close to him or don't make any more noise, he will return to patrolling the area. While traversing this area, you may see him walking around, but if at any point you accidentally step upon the rubble, it will make a loud noise, and he does not like this very much. Taking a look in the editor, we can see a little bit better how this works. The enemy here is simply just a navmesh agent upon a navmesh that is baked in with Unity itself. There's 6 nodes that are placed along the path the player may take, and he simply just travels between them. I chose this implementation over a random walk cycle, as when I had him patrolling randomly in a test world, he would often get stuck in corners or stay so far off the path he would never actually interact with the player. Heading back into the game, you will see it's actually possible to create a noise and not get caught by the enemy. Upon not finding the player after investigating it, he will return to patrolling. This seamless transition between the various states is handled by the state manager system which I implemented. Heading into JetBrains Writer, we can see how I implemented the state manager. I first created a state machine, an abstract state, class, with the methods for run current state, execute, and respond to sound. In the state manager I then create a state manager called current state, and in the start function set that to be the state of sleep, and then proceed to run it, and then execute it. If we look into the sleep, we can see only until the door is open, he will be doing nothing else, and then we'll switch to the door scare state. In State Manager, we provide all the functions for switching between states, and when that door scare state is ran, it gets the component door scare and sets it to the current state before running it, and then putting that into the execute. Door scare has a little bit more logic, and in the execute, it first checks to see if he can see the player. This, of course, is done just with a small physics check sphere, as his sight range is extremely low as he is a blind AI. And provided he can't see the player, pretty much only if you are right up against him, he will continue to walk to a given node, which is right up next to the door. And then once he reaches that destination, he will wait 5 seconds before switching into the patrol state. If at any moment he sees the player, he will switch to attack the player, or else if at any point he hears a sound, he will switch to chase that sound. Allowing the agent to respond to sound proved quite difficult, so I ended up on this solution. I created this, which is a class that is on every single piece of rubble in that room. When stepped on, it will play the sound, and then it will do sounds.makeSound. In here, it checks to see if the enemy is within range of that sound, and if he is, it will go, and it will get the current state, and then run the respond to sound of that in whichever state it will be, which will switch him to the chase noise, and the logic in there is similar to many of the other states. There are 2 other AI agents in this game, the first of which being a trapper. He is in this room over here. He works ever so slightly differently, as he is not blind and is able to see the player. He places traps around the map, and as you can see, whenever you stand on one, he comes for you. He is able to see and follow exactly where I am. This perception system works very simply by using a raycast to make sure not only if the player is in range, that also he is not hidden behind any walls or anything. The third and final AI is also implemented using a very similar state manager system. However, while this guy also will look at you, he will kind of stay a set distance away unless you look at him for far too long, in which case he will get annoyed, and then that is when he decides to attack, and he is inescapable at this point. Finally, we have the procedurally generated maze. This is generated using a depth-first search algorithm to ensure that the start point and end point, there will always be a clear path between them. Originally, the plan was to have the stalker enemy patrol within this area, but at the start of the project, we had opted to use navmesh, and as we soon came to find out, that became a huge limitation when doing this, and we were unable to figure out how to get them to work properly within a procedurally generated maze. Despite this, we decided to keep it in the final game as it demonstrates our thought process as well as the limitations of some of the things we decided to do, as well as what we could do in the future with this idea. Overall, I'm very proud of what we did with this game, but in hindsight, there's a lot of things I would have done differently if I were to do it again. For one, I believe the AI agents should have worked off the one state manager, which is what the original idea was when I created the one for the blind AI. However, when my teammates came along and made their AIs afterwards, and they had them run off a very similar state manager system rather than the same one. I believe the way I made it was quite simple, to just override the commands and have them all work off the one, which is definitely something I would look into if we had more time. I would have also possibly used A-Star or Dijkstra's algorithm for pathfinding to avoid the limitations, such as with the maze, as we were unable to get the nav mesh to work with the procedurally generated maze. And there were also some issues if you were asking the agents to calculate a path rapidly would often lead to jittering. I would improve the procedurally generated maze to make it a more focal point of the game, as currently it kind of is just there sitting as what could have been. And I would have also made the agents interact more, such as the blind AI reacting to the noise of the traps going off, and then maybe the stalking AI being scared of the traps going off, so it was this kind of balancing act between managing all three AIs in the one room. Overall, I believe I've demonstrated quite a good understanding of the game AI techniques, and I believe I will be able to use these techniques in my own games in the future.